Matt from the Dirty Lab Coat, and I am here today to do a demonstration for you guys on carrying capacity. And for this, we're going to be using our favorite microalgae that is marine-based. This is Nanochloropsis. So we're going to be growing Nanochloropsis. You guys have kits for that. And you're going to be putting an equal amount of Nanochloropsis into, here I have 7 bottles, small 50 ml centrifuge tubes. Self-standing ones are our favorites with the caps. Okay. And from here, set that aside for a few minutes. And from your pond of brine shrimp, and this is basically a 5-gallon kit for Nanochloropsis, and then we're going to add brine shrimp cysts to it. I like to catch them with, this is just screen, so this is window screen that we fitted into a cap. We have these available online as well. But basically you're going to fish out some of these organisms and put them into, so you're concentrating them so you can pull them out. We have these old pickle jars we have at the house. You can use any kind of a mixing bowl or anything just to do that really fast. So what we're going to do is we're going to do a carrying capacity experiment for oxygen, which means we're going to add into each container 0, 1, 2, 4, 8, 16, 32 brine shrimp. And then we're going to cap the containers. And we're going to place these inside of a bright area so that there's light that will get in there to result in photosynthesis to occur. So the sunlight will hit the algae will produce oxygen, which should be able to carry a certain number of individuals of the brine shrimp variety to keep them alive, to provide them enough oxygen. So at a certain point, we'll have more animal mass than plant mass can support. So we'll find out in 24 hours what happens, but we should see a difference. So right now, I'm gonna go and take my pipetter here, and I'm gonna pull up brine shrimp, the appropriate number for here. Let's go. $132, we did it. Okay, now let's set this aside. Now I had gotten some algae from here already. I'm gonna take Hi, this is Matt. It has been a little over 24 hours and we have some results from our carrying capacity experiment. We'll start off over here. This is our 0. There's no organisms in here. And you can see that we have bubbles of oxygen that have formed. That's good. Here we have one brine shrimpy in there. Where is it? There it is, swimming around at the top. Also oxygen bubbles. So we have a net positive with the oxygen. Number 2, we've got 1. The other one's in there somewhere. There they are. And now we go to 4. All of them happy as can be and still net positive with oxygen inside. 8. Here we have all of them in there. None at the bottom dead. Happy swimming fast. But uh-oh, here comes 16. What do we see in here? I see nothing swimming, nothing going on, but I do see a bunch of stuff at the bottom. Let's give that a little shake. Uh-oh, we've got some dead guys in there. Are any of them still kicking around at all? They're gonna slow down. So if you watch carefully, after about 12 hours, these 2 top ones start to swim, or they'll start to. You'll see them begin to. The O2 levels will go down. They'll start to slow their motion, and they'll start to go to the bottom. So you can track all that stuff there. So carrying capacity for Nanochloropsis with this. Don't tell your students, but we're talking somewhere in between 8 and 16 organisms per 50 ml tube of Nanochloropsis with an optical density that's around 35 millimeters. So this is Matt from Algae Research and Supply doing the carrying capacity experiment. Thanks you guys, and keep on pushing aquatic science. Bye.